This is your homework video for lesson 1-7. We've got worksheet with mean, median, and mode, and then a couple questions from the textbook as well from some mean absolute deviation. So starting here on the worksheet, we're just going to be finding the mean for these first 4 questions. To find the mean, you add up all your values and then just divide by how many there are. This is the average. Okay, so feel free to fast forward through me punching things in the calculator, but I'm going to add these all up. And then once I get that number, I'm going to divide it by how many there are. So I'm going to write it down just so I can show my work. But if you count this up, 2, 4, 6, 8, there's 9 of these. So I added them up. I'm dividing by 9. And my answer here is 1572.7. It doesn't say how to round it. So 78 is the answer they gave you. They rounded that last decimal spot, but it didn't tell you how to round it or how many places to go. So anything close to that is good. Okay, next one. There are 2, 4, 5, 6, 7, 8, 9 again. So we're just adding these up. For a total of 84 divided by 9. And that is 9.3. Now, this type of graph, every single one of these dots counts as one entry. Okay, so if I was going to make a list, this is 3, this is 4, there's 2 5s, 5, 5. There's a 6, there's no 7, there's 2 8s, there's a 14, there's a 23, and there's a 29. So when I add these all up, I got to make sure I have 2 5s and 2 8s. Okay, and that's 105. And I'm going to divide that by how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when you divide by 10, the decimal just moves. So this will be 10.5. For that one. These are the ones that take the most work, so we're almost done here. Number 4. Just going to add all these up and divide. 1, 2, 3, 4, 5, 6, 7, 8, 9 again. So 4. Divided by 9, and you get 5.5 repeated, 5.56 if you round it. Okay, down to the bottom here. Now the median is your middle number. So they need to be in order first of all. This one's already in order, so that's good. So you can knock off your smallest and largest until you get down to the middle. And you're left with your answer right there. It's 8. This one is already in smallest to largest order, so you can knock off smallest and largest until you get to the middle, and that's 79.7. These are already in order, so you knock off largest and smallest, largest and smallest, largest and smallest, largest and smallest. Now you're left with 2 of these, so you have a 5 and a 6. Well, it's always the number that's right between them. So right between 5 and 6 is 5.5. If you didn't know that, though, or if they're numbers that it's not as easy, you're going to add those together and find the mean of those 2. So divide by 2. So you add them up. There's 2 of them. You divide by 2. This would be 11 over 2, which will get you the 5.5. These also in order, so smallest and largest. Two numbers in the middle, But in this case, they're both 5s, so there's the number in the middle of 5 and 5 is just 5. Okay, the mode. Mode is easy. It's the most. Which one appears the most? Now, you can have more than one mode. Now, look, 18 appears once, 26 appears once, 10 appears once, but 7 is there twice, and 1 is there twice. Nothing is there more than that. And so those are both the modes. It's 1 and 7. Same thing here on number 10. The ones that appear the most are 70 and 71, and they're tied. And so both of them are the modes. Car weights. Yeah, you kind of got to sort through this, but I see this one twice, and I don't see any other ones twice. So 1240 is the mode. And this one, the only one that appears more than once, is right there. That's 30. And just to be clear, just because something appears twice doesn't make it the mode. If one of these had 4 dots, then 42 would be the mode and not 30. It would not be included because they're not tied. The only way they'd be both the mode is if they both had 4. Okay, so it is the most. It's not any one of them that has more than 1. It's just the one with the most. Okay, and the range is from the smallest to the largest. How far does this data range? Is it really centralized or is it really spread out? Does it have a big range? So the smallest one here is a 1 and the biggest one here is a 4. So the range, you subtract those two. How far apart is the largest number from the smallest number? 3. These are in order for you already. So the smallest is 47. The largest is 69. So we want to know how far apart they are. So you're doing 69 minus 47. So the range from smallest to largest is 22. These are in order. Smallest, largest, you're going to subtract. And that comes out to 19.5. And 16, smallest is 10 and the biggest is this large number. You're just subtracting those numbers. So you're just taking 10 away from this. So it's going to be a 29 instead of a 39. And there's your range. So quick review on the mean, which is your average, the median, which is your middle, the mode, which is your most, and the range is the distance from the smallest to the largest number in your data. Okay, so that's just a quick review there. Now we're going into the textbook. We are doing numbers 1 and 2, so this is lesson 1-7. We are on page 51, numbers 1 and 2, and then 6, 7, 8. Now, 1 and 2 are going to cover mean absolute deviation. You basically find the mean twice. So you find the average, and then you're going to see how far off all of the data is from the average. You're going to get all these new numbers, and then you're going to average all of those. And that number tells you how centralized your data is or how spread out your data is. So the mean absolute deviation tells you how erratic things are or if it's very consistent, basically. All right, so number 1. We're going to calculate the mean absolute deviation for the run scored by the softball team on page 50. So I'm going to slide over here. Right here, I'm going to go ahead and write these out. We got 0, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 4, 4, 5, 5, 6, 6, 7, 8, 10, and 12. So those are all the different pieces of data. So I'm going to add all these up. I'm going to divide by what I got here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I believe I have 21 here. So 3 and 4 is 7, 8, 11, 13, 15, 17, 18, 19, 20, 21. Yep, so 21 numbers. So I'm going to add these all up in my calculator, and I'm going to divide by 21. That will get me the mean. I'm not even close to done yet when I get there, but that's where you start. So 0 plus 1. You can put it in if you want to. You don't have to, obviously. 1, 1, So I get 87. I'm going to divide that by 21. And for the sake of this exercise, I'm going to round that to 4.1. So the mean is approximately 4.1. Okay, so I'm kind of halfway done. Once I've got the mean, I have to subtract every single piece of data from this. And what I'm doing is saying, okay, my mean is right here, 4.1. Sometimes your data is all really close to it. It could all be 4s and 5s and have that average. But we've got all of these big spread out numbers. Still has that average. So the centralized number could be the same whether all the data is here or whether it's spread out like we see here. When we calculate the mean absolute deviation, the smaller that number is, the closer the data is, more clustered, we say. But if we get a big mean absolute deviation, it could represent something like this, where the numbers are much more spread out. Now, we don't need to subtract this a million times for each one. So just for each group of numbers, so the 0, the 1s, the 2s, and instead of writing it a bunch of times, we're just going to use multiplication to get to that. So 4.1 minus 0. How far is the average, 4.1, from this data point of 0? Well, it's 4.1 away. And there's only one of those. So I only need it once. How far is our average from these 3 data points, the 1s? Well, when I subtract those, that's 3.1. So the average is 3.1 away from these data points there. Now, you could write it 3 times, 3.1 for this one, 3.1 for this one, 3.1 for this one. But I'm just going to say times 3. And if you added those all up together, that's going to get you 9.3. And in the end, just like here, we added them all up and divided by 21. We're going to add all these up and divide by 21. So we're technically getting 21 different pieces of data, but here we're just going to count all 3 together. So we got 3.1 3 times, total of 9.3. All right, what about for the 2s? How far away is the average from 2? That's 2.1, and there's 1, 2, 3, 4 of those. So 2.1 times 4 is 8.4. Then how about the 3s? 4.1 minus 3. That's 1.1, and there's 1, 2, 3 of those. So 1.1 times 3 is 3.3. What about the 4s? 4.1 minus 4. That's 0.1. It's only, the average is only 0.1 away from both of these. And so that's 2 of those, so that's 0.2. How about 5s? 4.1 minus 5. You're going to get a negative 0.9. Now we are measuring distance. How far is it? And so when you measure distance, you never give a negative answer. So we talk about the mean absolute deviation. So the absolute is talking about absolute value, which we already covered, makes things positive. And this is the reason. We're judging distance. It doesn't matter if it's distance up or distance down. Okay, just how far is it? So we don't want to use a negative number. It is 0.9 away from 5. So no negatives here. And there are 2 of those. So 9 times 2 is 18. So this is 1.8 for 2 of those. How about the 6s? So 4.1 minus 6 should be 1.9. Again, if you subtract this direction, you're going to get a negative, but we're only taking the positive. There's 2 of those. So we're going to times that by 2. That's 3.8. Got 4.1 minus 7. Should just be one more, right? 2.1. 2.9, I mean. And there's only one of those. So 4.1 minus 8 would be 3.9, one more. 4.1 minus 10, that should be 5.9. And 4.1 minus 12 is 2 more, so 7.9. So I now have 21 new pieces of data. Now I've substantially lowered the total number of things I've got here because I've done the multiplication, but I have 1 here, 3 here, 4, 3, 2, 2, 2, 1, 1, 1, 1, 1. That's 21 total. So now I got to add it all up and divide by 21. So what these numbers all individually represent is how far away each piece of data is from the average. So now we're going to go ahead and represent all of these numbers with one concise averaged number. So to do that, you have to find the mean. So I'm going to go ahead and add these all up. So 4.1, and it's going to be the three of them together. So that's why I already did this. So plus 9.3, plus 8.4, 3.3, 0.2, 1.8, 3.8, 2.9, 3.9, 5.9, 7.9. So I get 51.5. I'm going to divide that by 21. And the answer in the book said about 2.46. And depending on how we rounded this mean up here is going to be how close we get. So I rounded this pretty severely, but there was a bunch of numbers and I cut it all the way down to just a 1. So that's going to throw my answer off a little bit, but not terribly. My final mean absolute deviation according to my work is 2.45, perfectly acceptable based on my rounding. Answer in the book says 2.46. I know that this is super close and I know that I rounded my number off pretty severely here. So clearly that's what's changing it to there, so I'm good. Okay, question number 2 right here. So I have 3 zeros, 1, 2, 3, 4, 5, 6 ones. So 1 times 6, so that's just 6. And I have 6 twos, 2 times 6, that's a total of 12. I've got 3 threes, total of 9, and then 1 5. Now, each one of those counts as a piece of data. So when I go to count up how much I have here, I can't count this as 1, 2, 3. Okay, there's 6, and there's 6, and there's 3, and there's 5. But when I add them up, I can go ahead and use these numbers. So 6 plus 12 plus 9 plus 5. You could add the zeros, but obviously they don't change anything. So my total here is 32 divided by my total here. So 1, 2, 3 plus 6 is 9. Plus 6 is 15, plus 3 is 18, plus 5 is 23. So if I do 32 divided by 23, something is wrong. Let's see. Oh no, that might not be wrong. I'm already looking at the answer key thinking it should match, forgetting that this isn't the final answer, right? We got to do all this work. So 1.39 is what I got. We're going to assume that's good. So again, I added them all up, divided by how many I have. I got 1.39. So that's my average, somewhere in the middle here. Now each one of these pieces of data, how far are they from the average? So 1.39 minus 0 is just going to be 1.39 away, but 3 times that happened. So 1.39 times 3. How about all of these ones? The average is 1.39. How far is that away from 1? Well, that's just 0.39, and that happens 6 times. So 0.39 times 6 is 2.34. Now that 1.3 average, how far is that from 2? So 1.39 minus 2. We'll create a negative, and we're just going to take the positive. So 1.39 minus 2, negative 6.1, 0.61. So we're just going to take 0.61. That also happened 6 times. So times 6 is 3.66. 1.39 minus 3 should be just one more than this. So 1.69. That happened 3 times. So times 3, 4.83. And then the 5 should be 2 more than this, so it should be 3.69. 6. And this should have been a 1 here, huh? 1.39 minus 3. I'm looking at my work here. I went too fast. This should be a 1. So 1.61 times 3, 4.83. Okay, I punched it in right. I just wrote it down wrong. Okay, and this is going to be 3.61. And that's the only one because there was just that 1, 5. So now I got to add all these up and find the average of this. So 4.17, 2.34, 3.66, 4.83, 3.61. Gives me a total of 18.61. That gets divided by the same number because even though it's only 1, 2, 3, 4, 5 numbers that we added up, there was 3 of these and 6 of these and 6 of these and 3. There was 23 total. So we're going to divide that by 23. And again, depending on your rounding, things can get thrown off. So we're going to go with approximately 0.8. Answer in there was 0.87. And it's possible that I could have slipped up somewhere in here. And that's why it's a little bit off as well. But some of it's the rounding. So the process is what's important, not did I punch every single number into the calculator. So on this type of question, you're going to pretty much get full credit if you show the process and you know what you're doing. It's not about having the exact decimal answer. Now, obviously, if you make big mistakes on your way, your answer is going to be off, and that you're going to lose credit for. But the process is what we're focused on here, not the exactness of the answer. All right, and let's finish this off with 6, 7, and 8. And these are just looking at these graphs and making sure we understand what they're called and what they look like. So number 6, which distribution of data is symmetric? Symmetrical means both sides are the same. You could cut it down the middle, and that's letter B. You can see it's centered. And now 7 and 8, I always used to get these mixed up. It says, which distribution is skewed left? To me, skewed left looks like C, because all the data is left. But that's not how you judge it. It's the opposite, actually. You judge it by what's called the tail. So this is the tail, the big long tail, the big long tail. Where's that? So skewed left is when you've got this tail going off here to the left. So for number 7 here, sorry, I was looking at the wrong one. So which one is skewed left? That's going to be letter A because the tail is on the left. The data is actually pushed to the right, but the tail is over here. That's called skewed left, and I used to always get these mixed up. And then number 8 is letter C, which distribution is skewed right because my tail here is going off to the right.